Hey everyone, welcome back to CFD Simplified. Post-processing OpenFOAM results manually? Too slow. In this video, I'll show you how to use Python to quickly extract and plot your pressure and velocity data, automating your workflow. Let's get started. Okay, so let's start today's tutorial video. So for this tutorial video, I'll be using the fluidized bed tutorial of OpenFOAM, and after running it, we are going to use those results and plot from there. We are going to plot the pressure and the velocity data using the Python. Okay, so let's first import that. Fluidized bed tutorial from OpenFOAM tutorials to our local directly. So for that, first open foam tutorials, then we have to go inside multi-phase, then we have to go inside two-phase Euler phone, then we can go inside RAS, and here you can find fluidized bed. So let's copy it to our home directory. Okay, let us check. Okay, it is here. So let us open it. Okay, yes, all right. So let me give you some brief introduction about fluidized bed. Fluidized bed is basically the some small solid particles are there. You can say, take the example of a small sand particles, and air is being thrown. So what is happening is like those sand particle behave, start like moving like a fluid. Okay, because of the fluid which we are throwing. So for example, we can take the example like one small rectangular plate we have taken and placed one small sand grains, and we are just throwing air at a very high velocity. So due to that high velocity, it is the air which is going to be flowing with that air, those sand grains will also be starting to get flow. Okay, so that is the fluidized bed. You can find it, you only have to type it on the Google, and many articles are there where you can read about fluidized bed. Okay, I'm not going to explain that thing here, because my primary focus in this video is to how to apply Python. Okay, so let's run it. So to run it, first we have to make this 0.org to 0. So to copy this 0.org contents to 0 directory, you can rename the 0.org to 0, but what I for the good one, the good way is to the good way is to this make a new folder 0, make a new directory 0, and copy all the contents of 0.org to 0 directory. Okay, this is a good way. All right, so first we have to run this block mesh has been made. Then we have to run set fields. Now what is this set fields? I will explain it later on, because I don't want to go into this right now. As I've already told, primary focus is to go how to use the Python. Okay, so yeah, now we have to run our solver, which is two-phase Euler form. Okay, so it will run. Okay, it will run, and it will take some time. So I'm stopping this video here, and we'll continue after its running will be completed. Okay, yeah. Okay, so this is being completed. So let's go into it. Yeah, so you can see that the time steps are here. Okay, I have already written this the the Python code for velocity uh, of air, for velocity of the particles, for the comparison between the both the velocities of the air and the particles, and for the pressure. Okay, so we will be using that. I will upload this on the Google Drive. I will upload this Python script on the Google Drive only, and provide you the link in the video description. You can go there and just download this Python script, and you have to only modify the path in it. Okay, so let me show you one. Like if I'll open the U.air.py, so this Python code is for the basically for the this the velocity of the air. Okay, like it will plot the velocity of the air. Okay, so only you have to do is change this path. Like my path is this one, for the where all the time steps are there, it is there inside the fluid aspect. So the path is this, your path may be something else. So only you have to change this and keep everything same. After changing it, only save it and run the Python script. So I will run that, and yeah, it will take some time, and yeah, you can see that the Python script has generated the plot for the velocity of the air. Okay, velocity of the air with respect to the time step. So total time step was 2 seconds. So this is the velocity of the air. Okay, you can save this one by click on this save figure, and go inside fluid aspect. You can give the name to U air plot and click on save. Okay, yeah. So it must have been saved. You can see that, yeah, it is coming, not png. Okay, yeah. So same, you can run the pressure one also. So I will just go into the pressure, and here you can see that it has given the pressure plot. You can just click on save, and save inside where you want. I'm saving it here, so giving the name this. It has been saved, closing it. Now let us run the comparison one. So I will just run Python 3 U. This one is for the comparison between the velocities of the particles and the velocities of the air. Okay, so I think I have not run the particle one. Okay, so first run the particle velocity. Yeah, so this is the plot for the particle velocity. Okay, so let us save it. Yeah, give the name part plot save. Okay, yeah, clear. All right, so it is like that. Now let us run the comparison one. Okay, so comparison u py, and yeah, you can find that this is the plot which is comparing the velocity of the air and the particles. Okay, so so likewise this specifically what I found great about the Python usage of the Python in the OpenFOAM or in the CFD is it is very helpful in making the comparison plot. Okay, that I feel very good in that. You have to do the things manually. You can do it with the help of the Excel also, but sometimes Excel you have to first extract the data and bring it to the Excel sheet, and then you can just make the plots. And beyond, if you use the Python, you don't have to convert it to the Excel sheet. Only you have to do is like write the code which can read your OpenFOAM data and after reading that open form data, it can automatically generate the results in the way you want. So that is the thing. Okay, so specifically what I like about the usage of the Python in the open form is like it is very helpful in generating the comparison plot. Okay, so yeah, so this is the thing. I will save this one also, like comparison plot. Yeah. Yep. Save. Let me clear this dominant. Okay. So yeah, so we have all the things. All right. So now the point will come is like how to write this Python plot. Was it there before? No. I have seen, I've shown you inside the OpenFOAM tutorial. No, it was not there. Basically, I will tell you the truth. I have written it with the help of the chat GPT. Okay. Some things I have modified it with myself also. I have the knowledge of Python also. But to save the time, I have taken the help of chat GPT, and you can also take the help of chat GPT. Okay. Because you don't have to use your mind and again and sit idle and sit in writing the whole code. Something is there, it is saving your time, so why don't you just use that? Because we have to do other things also. CFD is not like only writing the Python code. Okay, yeah, knowledge has to be there, because it is not going to give you the correct result or not. That is the thing. But if a chat GPT or some other AI tool can generate the code for you, it is saving your time. Because if you are a CFD engineer, for example, so you have to do many things. You only don't have to make the plots. After making the plot, you have to generate the make the report also. Sometimes you have to give the presentation also. Okay, in front of anywhere where you, if you are in academia, you have to give the presentation of the result. So you can invest your time at that part, making the report looks good, making a good presentation, rather in writing the code. Okay, so yeah, chat gpt is helpful. I'm not saying, but in CFD it is helpful. Okay, I'll make a video in which how you can just use the chat gpt to generate the codes, or to remove the errors for your in your open form codes. Okay, yeah, it can remove the errors. Okay, it can remove, it has removed when I was working in my for my MTech thesis. It has removed. Okay, it has removed. So yeah, so it is there. So let me open one. So how ChatGPT can generate? Okay, so I will show you in another video that how ChatGPT is helpful in generating the Python codes. Okay, so I will just in that we will write it down. So we will see that how it is writing, and there we will be using it and trying to generate the results of the plot which we want. Okay, so let me open one and to show you, like, okay. So one thing is like how, what is that thing? What is the Python library which can read the open form data? Okay, the main thing is that. So that library is this fluid form. Okay, fluid form is the Python library which can read the open form data and convert it in the way so that it can be useful to generate the results in the way we want. Okay, so because open form results are in there in some other form. Okay, and Python has to be there, so that has to be converted so that Python can read it. Okay, so to read it, this fluid form helps. Okay, so it converts it in that form. All right, so yeah, so first one is to this import numpy, import matplotlib fluid form. Okay, then you have to specify your case directory path. Then after that, these are like, it is this line is for reading the time step. Okay, so you how to read it, how it is given in the form. So first that description is there. Okay, So then some things are here, okay. Define, get, valid, prove, index, and everything, okay. So and after that it has generated the plot, okay. So like this you can just write your Python code, or you can take the help of chat GPT or any other AI tool to write the Python script for you for the post processing. And it will be very helpful, okay. It will be very helpful for you, and it give you the good, and it gives you the good result, okay. Because the more you show the plots, the more it shows that, okay, it shows your result, okay. Like, okay, this is the results which you have got. Because as I've already told in the previous video also, is like people are having the CFD data with them, but they don't know how to represent it, okay. And by making the plots is a very good representation of their work which they have done, okay. So yeah, so I will make one separate video in which I'll be explaining this whole Python script, okay, like line by line. We will I The main idea for this video was like to only to show you like how Python is helpful, okay. So I'm not explaining Python, this Python script. I will make one separate video, and in that I'll be explaining each and everything, and then we will be writing our own. I will not take any help of the chat GPT or any other AI tool. We will write our own Python code, and there you can see that how you can also write your own Python code, okay. Yeah, let us end this video here, okay. I hope you have enjoyed, you have learned, you have seen that how Python is being useful, and how you can just, by writing the Python code, you can just extract the data, extract the results, and generate beautiful plots of your CFD results, okay. Now you know how to extract velocity and pressure data from OpenFOAM results, automate post-processing using Python, compare different CFD fields using Matplotlib. Want more Python plus OpenFOAM tutorials? Let me know in the comments. If you found this helpful, don't forget to like this video, subscribe to CFD Simplified, drop your questions in the comments.